How do you feed over 1 billion people? Well, you need a revolution. And India had one, the Green Revolution. But here's the catch. That revolution was powered by chemicals. Today, we're going to break down the hidden costs of all that progress. We're going to look at the incredible scale of agrochemical use in India and what it really means for our environment, our health, and, the future of farming itself. So let's just start with a number that's, well, it's pretty hard to wrap your head around. 55,194%. No, that's not a typo. That is the growth in India's pesticide consumption, which shot up from just 154 metric tons back in the early 50s to a staggering 85,000 metric tons by 2010. It just shows how much the entire agricultural system went all in on chemicals to get bigger yields.
So you have to ask, right? How did we get here? How did India become such a massive player in the agrochemical world? Well, this whole boom was really born out of necessity. The urgent need to grow more food for a growing nation. But in solving one problem, it created a whole new reality for India's farms and its environment. And when we talk about scale, we're not kidding. India's agrochemical footprint is absolutely immense. It's not just a user, it's a global powerhouse. We're talking about being the third largest consumer of pesticides on the planet and #1 in its region. It's also a manufacturing giant, second only to China in Asia. Oh, and it's also the world's second largest consumer of potassium fertilizer. So yeah, this is not a small-scale issue. It's a huge piece of the global food system.
But hold on, here's where this story gets a little more complex. Even though the total amount of chemicals is huge, if you look at how much is used per hectare, per field, India's rate is actually pretty low. It's just a fraction of what's used in places like the US or Japan. So what does that tell us? It suggests the real problem might not be just how much is being sprayed, but what's happening to those chemicals after they hit the ground. Okay, so let's dig into those hidden costs, starting with fertilizers. They're supposed to make crops grow, right? But what happens when a huge chunk of that fertilizer never even gets to the plant? Well, that's where the trouble really begins.
It's honestly kind of shocking how much fertilizer just goes to waste. Take a look at these numbers. For something as important as nitrogen, plants only use about 30 to 50% of what's put on the field. For phosphorus, it's even worse, just 15 to 20%. And for some of the smaller nutrients, like zinc and iron, we're talking a tiny 1 to 5%. So where does all the rest of it go? It just washes away.
And that runoff, all those unused nutrients pouring off the fields, has a name for the environmental damage it causes: eutrophication. Sounds a bit complicated, but the idea is actually pretty simple and incredibly destructive.
Think of it like a 4-step vicious cycle. First, the runoff carries all those extra fertilizers into our rivers and lakes. Second, those nutrients are like steroids for algae, causing this massive explosive growth called an algal bloom. Third, when all that algae eventually dies and starts to decompose, that process sucks all of the oxygen right out of the water. And the result? Step 4, a dead zone, where fish and everything else that lives in the water literally suffocate and die.
And you might think, okay, that's terrible for the fish, but this problem doesn't just stay in the lakes. The same nitrates from that fertilizer runoff can seep down into the groundwater, the very water that we drink. And once those levels get too high, above 45 parts per million, it stops being just an environmental issue. It becomes a direct threat to our health. All right, so we've talked about what washes away. Now let's talk about what stays behind. Pesticides are designed to kill, of course, but some of these chemicals stick around for a shockingly long time. They create this persistent problem in the soil, in the food chain, and for us. When you break down the types of pesticides being used in India, one category just jumps off the page: insecticides. The chemicals designed specifically to kill insects make up a massive 60% of the total. That is way more than any other type. And that heavy reliance means we absolutely have to understand what's actually in them. So if we zoom in even closer, we see that the market is really run by two main types of chemical compounds. First, you've got organophosphates. They're very effective, but also highly toxic, and they make up almost 3/4 of all insecticides. But it's that second group, the organochlorines, that poses the biggest long-term threat. This chart really lays out the differences. You've got some chemicals, like synthetic pyrethroids, that break down pretty fast, and organophosphates degrade faster too. But then Then you have the organochlorines. They are highly toxic and, as you can see, just unbelievably persistent. And the most notorious example of all is DDT.
Seriously, just let that number sink in for a second. More than 15 years. A chemical sprayed on a field can still be active, still be harmful, for a decade and a half, maybe even longer. It doesn't just go away. It stays in the soil year after year, with the potential to be absorbed by future crops or wash into our water. So, after all that, you've got to be wondering, is there a way out of this chemical-heavy cycle? Well, the good news is yes. The solution might just be to turn back to nature and embrace a totally different way of controlling pests.
And this is where biopesticides enter the picture. So, what are they? Well, instead of being cooked up in a lab, these are substances that come from natural materials. We're talking about things like extracts from plants, like the neem tree, or even specific bacteria and fungi that target pests without all the collateral damage you get from their chemical cousins. So, how do these two approaches really stack up against each other? Let's put them head to head and really weigh the options for a greener farming future. And wow, when you lay it all out like this, the difference is it's night and day. Chemical pesticides are like a bomb. They kill the bad bugs, but they also kill the good ones. Biopesticides are more like a sniper, targeting only the pests. Bugs can build up resistance to chemicals, but that doesn't really happen with biological controls. And maybe the biggest difference is what's left behind. Chemical residues can be toxic for years, while biopesticides are harmless and break down completely. And, this isn't just about the environment. It's about economics, too. As people all over the world become more aware of these issues, the demand for food that's grown safely and sustainably is just skyrocketing. This creates a real financial incentive for farmers to make the switch, because their crops can actually be worth more on the global market. The positive impacts of going green just keep stacking up. It naturally promotes organic farming and helps restore balance to the ecosystem. It protects farmers themselves from being exposed to all those toxic chemicals, which addresses not just accidental poisonings, but also the tragic fact that these pesticides are sometimes used for self-harm. At the end of the day, it just builds a food system that's safer for absolutely everyone, from the person in the field to the person at the dinner table. So this is what it all comes down to, right? The chemical revolution helped feed a growing world, but we're now seeing the true cost. The challenge for us now is to innovate with nature, to build a food system that can keep sustaining us without poisoning our planet. That choice between those two futures really depends on the decisions we all start making today.